All right, good morning and welcome back to Pre-Calculus. We are talking about sequences and series. Okay, so it says match the function with its graph. This is why in college algebra, that's one of the reasons why in college algebra we had you memorize the different shapes of the different functions, because later on in your careers, you're going to have scatter plots, you're going to have data, and they're going to say, what model do you think best explains this? So you're going to have to match the shape of the dots to the shapes that you know. In this case, what I'm looking for is shapes that kind of look like a square root function. Now you might ask, well, why are these discontinuous dots? It's because remember the domain is over the natural numbers and the whole numbers. Okay, in this case, it's over the natural numbers. So if they were over the real numbers, we would have a line like this. Okay, which would include all of the numbers between here. But in this case, we're sequencing over the natural numbers. So there's a value for 1, a value at 2. We don't have a value for 1.5. Okay, that's not there. So what I'm doing is I'm looking for the shape that best describes what a square root function looks like. If you remember what square root function looks like. Okay, it's okay if you don't. I wish you would, but it's okay. So square root function, something like that. Okay, so just to go back to your college algebra, your algebra 2 classes, and remember what there's like 11 functions that they give you. If you took in the pre-calculus trigonometry, you've now taken trigonometry, I think you have a grand total of like 15, 18 functions you have to remember the shapes of. Okay, that's okay. More so if you include, when you get to conic sections, you have to remember those shapes, and then more so if you graphed in polar coordinates. That's the trigonometry thing. So if that's not making sense to you, that will someday. But those are a whole bunch of shapes you get to remember what they look like. So in this case, we're just going to guess B. Okay, because that kind of looks like a square rootish function here. This one looks more like a 1 over x. These guys, I can't quite tell, but this one has a solid line, so that's not going to work out. Okay, but this is a constant. So we'll go ahead and check. All right, gray. Didn't even wait for the green line, I know. Okay, we'll go on to the next one. Okay, so again, square root function. Okay, I don't understand exactly what they're doing with this one. Oh, f of x equals, okay, that's not going to be the right answer because f of x is not a sequence. That's a regular function. So we're going to pick this one instead. Okay, and just if it was a sequence, it would be part C. But it's a function with real numbers, we're going to pick D. So you see what the difference is, and that's all they're really asking us to do is to distinguish between the two ideas: function real numbers versus sequence natural numbers. Okay, that's it. All right, now this funny looking thing. This is a capital sigma. All right. And all this means is add up the stuff that comes after it. Okay, so the way I tend to write this is I put serifs on mine. Okay, so that's this little hook here is a serif. Okay, that's all the little hooks when you have like when I write my ones. Okay, these are serifs. So if you ever really wanted to know all about like how letters are created when you're printing things or all about different fonts, this would all be that. Okay, nobody's going to care. And then we go from I is equal from 1 to 4. And all we're going to do is add up for values from 1 to 4. So we're just going to say, okay, I equals. Okay, it's often that people use I, J, K, M, or N, maybe some P's. Okay, those are the letters that people generally use for counters. I don't like using I myself because I typically has a different job. It's equal to the square root of -1 often, but not always. Okay, but very often I is used as a counter. But these are generally the letters you want to use for counters, just by convention. All right, and all we do is add these things up. Okay, so I'm going to make a little table for myself here and then add them up. So we have what? 5i minus 1. So we have 5i minus 1. We've got to go from I equals 1 to 4. So when I equals 1, we have 5 times 1 is 5. 5 minus 1 is 4. When I equals 2, we have 5 times 2 is 10. 10 minus 1 is 9. when I equals 3, we have 15 minus 1 is 14. And then we have I equals 4. 5 times 4 is 20. 20 minus 1 is 19. And we're just going to add these things up. Usually what you want to do is find some kind of cutesy way to do this. Unfortunately, I don't see one. Like if we could add the first one and the last one together, that might cut down what we have to do. But since we only have 4 numbers to add up, right, 1 through 4, that's not really going to be that much of an issue. We could probably do this by hand. That would probably be a better exercise for me specifically, but for all of us. Okay. So back in the days when, yes, you add up your grocery bill as you're getting all of your groceries. Because I got thrown out of a Walmart for using my calculator once, so no, I'm not kidding. They asked me to leave. You can't have that in here, sir. Okay. 46. There you go. Hooray. And then that's pretty much all there is to it. So, and I would recommend this for a long time. Well, not a long time, but until you get comfortable with this notation and what it means. I really do. Even when you get to harder problems, the easiest way to untangle this is literally write out what is the stuff you're adding up. So it looks kind of cryptic, horrible, and really intimidating when they write it like this. But if you realize, like, I'm just at 4 plus 9 plus 14 plus 19, that's all we're doing. Like, this is not intimidating at all. I mean, we're allowed to use a calculator, but even without a calculator, right, we would say, okay, the 13 plus 14, and then add that together, and then add 19 to it, and then go with that. So if you have to do this with mental math, that might be a little intimidating if we don't have a lot of practice, but mostly this is not an intimidating problem. Okay, we'll continue on our way. And then express the sum as a fraction in lowest terms. Okay, so we're going to go from j from 2 to 6. Okay, so again, we have sum j is equal to 2 to 6. I like j a little bit more. I'm not an electrical engineer. In electrical engineering, j is equal to the square root of -1, only if you're an electrical engineer. They don't know how to spell. Okay, so that's 1 over 3 raised to the j. So all we're going to do here, and we're not getting fancy here, okay? They just want us to plug in the numbers and add them up. And for a while, at least the beginning parts of this, I would recommend the same thing. So we're just going to make a little table here. J equals 2, 3, 4, 5, 6, and we're just going to add these things up. So this is going to be 1 over 3 to the second power. That's going to be 1 over 9. 1 over j to the 3, 1 over 27, 3 to the 4th, 1 over 81, 3 to the 5th, that's going to be 1 over, what is that going to be, 243, and I don't know what 3 to the 6th is offhand, so I'm going to cheat a little bit and say 3 to the 6th power. Okay, it's 729. Okay, we could probably be a little bit cutesy here, but here's what I'm going to have you do. Okay, we're just going to type in that. Don't add these up and then say 1 over. That's not the same. Okay, so be careful when you're doing this. But all we're doing is we're adding these guys up. Okay, so we're just saying, okay, well, 1 over 9 plus 1 over 27. Okay, plus 1 over 81 plus 1 over 243 plus 1 over 729. Okay, and then say equals, and I guarantee you, Alex ain't gonna like this answer. Okay, so what you're gonna do is you're gonna go to the math button here, and all of your calculators have this. Okay, if it's a less fancy calculator, you have a button that looks like A, B over C, like that. And that'll convert your number to a fraction. And that's what we're going to do. Okay. And hit equals for that one. And say, oh, this is 121 over 729. Or if we had to do this with common denominators and fractions, okay, these are all multiples of threes. So we would just say, okay, well, I've got to multiply this by, I guess we have this 3 to the fifth. So this is 3 to the fourth. How do we get to the 5? We're going to say, well, this is 3 to the fourth over 3 to the fourth. 3 cubed to 3 to the fifth. So we're going to say this is going to be 3 cubed over 3 cubed. 3 to the third over 3 to the fifth, that's going to be 3 squared over 3 squared, and then times 3 over 3 and add them up that way. And we could do that, okay? So that's how you convert it back to a fraction. I feel every time I do this, I feel really bad because I remember my fifth grade math teacher told me that there was never going to be a calculator that would do this. So I had to learn how to do this by hand when I was in fifth grade, and I did not like that lady. So every time I do this, I feel like I'm dancing on her grave. Sorry, Mrs. Smith. She was a reasonably good. Well, let's see if she was a nice lady. She wasn't, but she was a reasonably good lady. She was a good teacher. So there we have it. So we're going to type in 121 over 729. Okay. Okay. We'll check. And she got me, she didn't crush my love of math. She did. But I survived her class, so that was okay. So there you go. That's our answer for this one. Let's see what we have coming up next here. Same idea. Find the sum. Just going to add these things up. We're just getting the practice of adding this up. And again, for the first couple of few problems that we're going to do this with, I would recommend just write these out so you get an idea of what's going on. Okay, so I'm going to go ahead and pause and stop the video. We'll probably be able to look at 7, 8, and 9. Sorry, I'm doing this to you. And yeah, we'll just do that. Okay, so I will see you in the next video. Thank you for tuning in.